This video is for 16.1 homework. So if you are still wondering or have questions about patterns and shapes and distribution of different data and how they're displayed, then be sure to follow along with this video. So number one shows us this histogram that has different cars. So we can see, right, there's one car that gets 5 to 9 miles per gallon. There are two cars. So you can all see all the different cars and the range of miles per gallon that they can drive with. So we're going to describe the shape and pattern and see what we can figure out from that. So before we even look at the answer, let's just take a look at the data itself. So, right, we can see here is our highest point. So, right, I do notice it goes up to that point and then it consistently goes down. However, I do see if I fold it in half, it's not exactly the same. Got more data over here than here. So the distribution, symmetrical means you could fold it in half and it's exactly the same. So my hands are not a good representation of that. So there you go, right? My hands are not symmetrical. There's a good chance that your hands are symmetrical. So not symmetrical. There is a set of twin peaks. Remember, our peak is the highest point here and here. And that tells me that the typical range is going to be between here. Most of our data falls within these two categories here. So let me actually kind of row over some of the answers here. So find our peaks. You can see it's not exactly symmetrical. It is increasing then decreasing, but not at a constant rate there. Hey, number two. So we're going to look for clusters, gaps, anything that doesn't fit into those patterns, any peaks. We're going to state the mode and find any conclusions we notice. So first we're going to look for gaps. So remember, gaps are where there's no data. So you'll have data on either side, but nothing in the middle. So how many gaps do we have? So there are blank gaps, clusters, or deviations. So how many clusters, so gaps, clusters, or deviations all together? So I don't see any gaps in here. Clusters are groups of data, right? So this just has one big group. And I don't really see a deviation as something like an outlier. It just really doesn't fit in. So there's really nothing that doesn't fit in. It's showing the height of this softball team, and they're all within about 7 inches of each other, which sounds right. So we find our peak is the highest point. Peak and mode are the same thing. So peak, mode, they're the ones that are the highest the most often. Using the blank, the most common height of softball players is, so what tells us the most common? So again, mode, peak, and here's my word, common, all mean the same thing. Number three gives us this data set and the dot plot of grades of Professor Berger's students. So here's all of their percentages on a test. So first we want to describe the shape of the data. So I can kind of see my peak here, right? If I cut that down the middle, there's 2 right next to it. Then they both have a gap. Then they both have 2, 1, 1, gap. Let's see how many gaps are there. Gap, 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 gap. So same on both sides. And a final point. So these ones are symmetrical. And so there's just, so we can see, right, they're symmetrical. It increases and then it decreases. We can see we've got these gaps of data in these places. So nobody got those scores. We can see we have a couple clusters. So there's a cluster here, a cluster here, a cluster here. So different groups. We can also see the height, the peak is at this score here. So use that information to answer those questions there. Number 4, the dot plot shows the distribution of books read last summer by students. So every dot is a student, and here's how many books they read over the summer. Which pattern in the data helps you conclude that most students read 4 books? So we can see, right, most students read 4 books. That is which of those vocabulary words? So remember the height, it's kind of like a mountain. Want to get to the tallest point of it. Number 5, the dot plot. Oh, I was like, same question. It is with a different question, same dot plot. So they have the number of books here read by students. Every dot is a student. How many people or how many students were asked about how many books they read? So remember, every dot is a student, which is a person. How many people answered that survey there? Number 6, the histogram shows the distribution of petal lengths for flowers in a botanical garden. So we can see from less than a centimeter, we've got 4 plants that have tiny leaves, all the way up to like 24 plants that have about 1 centimeter to a centimeter and a half leaves. So which statement best summarizes this data here? So, right, we can see we've got the peak is up here. I don't see any gaps in our data. So, right, they all have at least one flower that fits into that category. Our cluster, right, they're all grouped together. So just one cluster. So let's see. So we've already said there is no gap. And this is there's a gap between 2 to 3.4. And that's not true. There is one flower. So there's no gap. Most of the petal lengths are between 1 to 1.9. So is that true? Is that where you feel like most of them are? The majority of petal lengths are greater than 3.9. So here's 3.9. So do you think most of them fall over here, or do most of them fall here? So it didn't ask for which category had the most. It just said, like, all together, are most of the flowers here or here? And there is symmetry between long and short petals. Not really. I don't see anywhere where I could fold that and make it match up. So decide. So it's definitely not one of these. So decide, do you think most of the petals are clustered here or bigger than 3.9? Number 7 wants us to evaluate x equals 4, y equals 6. So let's substitute those in. So 4 times 4 minus 6 plus 15. So we need to use our order of operation rules, our GEMS. So, there are no groups. There are no exponents. So we need to multiply or do the opposite, divide. So here's our first problem. And then we'll do that, bring everything else down. Then we'll finish adding and subtracting that problem. Number 8 wants us to write an equation that models this. So we need to see, how do I get from here to here? So we could add 6, but this isn't adding 6. So how do I get from 1 to 7? Well, every time we times by 7. So we're taking x and we're timesing it by 7, and it equals y. So make sure we write an equation with an equal sign. So every time we took x, times it by 7, right? 1 times 7 is 7. 2 times 7, 14. But we're saying for any numbers in this table, this constant rate here, using x and y, what is that problem? So timesing it by 7 equals the bottom, which is y. Okay, we're going to simplify. So again, we still have to follow GEMS, even when there's not numbers and we've got variables. So no groups, no exponents. I don't see, there is multiplication, 4 A's, 2 A's, 7 B's, but since we don't know what A and B are, we can't multiply or divide. So we're looking for adding and subtracting. So we have to group common things. So do you see any other A's? So I see 2 A's. So I notice, right, this is subtracting those 2 A's. Move my head over here. Do we have any other numbers? So here's 8. Here's just a 4, but it's minus 4. And then we have no other B's. So put the A's together, make sure we're minusing these one. Put our numbers together, we're minusing these, and then our B's there. didn't have anything to combine with those. So I think that is everything. So if you have any other questions on this homework assignment, be sure to let me know and we can set up a time to meet about those clusters, gaps, and peaks.